Hello students, this is the next video of classification of elements or the modern periodic table given by Henry Moseley in 1913. We have discussed certain characteristics of this table and here I have drawn an edited table. That is the portions we need I have drawn and which are not in our syllabus. I did not draw those portions. So it is a changed or an edited or a mini table, mini modern table. So we have discussed this, that this table, this modern periodic table has 18 vertical columns from 1 to 18, this like this, the vertical columns, and we call them groups. And there are 7 horizontal lines or horizontal rows, and these horizontal rows, they are known as periods. 1, 2, 3, 4, 5, 6, 7. 7 periods are there and 18 groups are there. 18 vertical groups are there. Now, in these boxes, different elements are arranged and these elements, they are present in a manner of their increasing atomic number. Not atomic mass, atomic number. So, from 1 to 20, I have written the atomic number as in our syllabus. Up to, we have up to calcium, which has 20 atomic number. So 1, 2, these atomic numbers, they are present in a consecutive manner. So different elements which are present in these boxes. First is the 1 atomic number is hydrogen, which is the lightest element. Then 2 is helium, which is an inert gas. This column 18, it is dedicated to noble gases or inert gases, and all are present in this column. And third is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. And then comes sodium, magnesium, aluminium, silicon, phosphorus, sulfur, then chlorine, and then argon, and then potassium, and then calcium. So these 20 elements are in our syllabus: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. So you have to learn the series with 1 to 20 atomic number. So this is very easy to learn. You read it few times and you will learn the series with their increasing atomic number. Now we should know some of the characteristics of periods as well as groups. So I am writing here some of the characteristics of groups. What are the groups? They are 18 in number. All of us know. I have told you 18, or we can say 18 in number, and they are vertical columns. So vertical columns, they are known as groups and they are 18 in number. The second characteristics of group is that the elements which are present in a group, differ by atomic number 2 or 8 or 18 or 32. That is, the difference in atomic number may be 2 or 8 or 18 or 32. We see this group. This is the first element, this is the second. They differ by 2. 3 minus 1 is 2. This is the third element in the first group, the same group, and sodium and lithium, they differ by 8. So I have written here, elements which are present in a group differ by atomic number 2 or 8 or 18 or 32. As we have to do up to group 4, so we can see 11 and 19, they are also differ by 8. So this is written here, this is the second characteristics. And third is valency. Valence, first we write valence electrons. Valence electrons in a group are same. When the valence electrons are same, then the valency in a group is also same. How can we say this? We can look at, suppose we are looking at first group. On the top, hydrogen is present, although hydrogen has a anomalous position. It is not perfectly in group 1. It can be put under group 17 also, as it has some properties like alkali metals and it has some properties like halogens. So if we take this hydrogen also, then in this, if we take the first group, hydrogen, lithium, sodium and potassium. So I am making the short notation of these EC of these. Hydrogen having only one electron, so this is of hydrogen. For lithium it is 3, so it has 2, 1. After this, sodium 2, 8, 1, atomic number 11. Then potassium 2, 8, 8, 1. So what does it show? The EC show that all the elements of the first group, they have 1, 1, 1, 1. 1 electron in its valence shell. So the valence electrons are same in a group. And what about the valency? Valency is the combining capacity, and this valence electron, it determines the valency of the element. As all have one valence electron, so the valency is also 1. Group 1 has the valency 1. And one thing more, so 2 points are clear, that valence electron are same and valency is same in a particular group. Now look, if we see the second group, beryllium 4, so the EC will be 2, 2. For magnesium, EC will be 2, 8, 2. For calcium will be 2, 8, 8, 2. As the atomic number 4, atomic number 12 and atomic number 20. So we can see that the valence electrons are 2. In the outer shell, 2 electrons are there. So the valency is also 2 of the second group. So the number of group determine the valency, and the valence electrons, it determine the valency. So what I have written, valence electron are same and valency in a group, in a complete group of, is also same. These elements below calcium, though they are also having the same valency. If we write other elements of this, lithium, sodium, cesium, francium. So these are the other elements of the first group, rubidium, cesium and francium. So all have valence electron as 1 and valency is also 1. As we go further from 3 to 12, this area, these elements are not in our syllabus, and these are known as transition elements. Group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From group 3 to group 12, they are not in our syllabus. Now coming to group 13. So 13, as you have seen, boron has the valency 5. So EC of boron will be 2, 3. EC of aluminium will be 2, 8, 3. As the atomic number is 13, can you make this? In the first shell 2 will be there, in the second 2 will be there, in the third 18 will be there if it is not the last shell. But if it is the last shell, then in 3 also, in third also 8 will be there. So aluminium has this EC 283 and 23 of boron. What we are seeing, that the valence electrons are 3 in both the cases and valency is also 3. Likewise, for carbon, the valence electron, carbon and silicon, valence electrons 4 and valency is 4. But as we go further, for nitrogen, oxygen, fluorine, neon, the valency of nitrogen, first I am making the EC of nitrogen. EC of nitrogen is 2, 5. EC of phosphorus is 2, 8, 5. So the valence electron are 5 in this case. Here the valence electron 6, valence electron 7 and valence electron 8. So the number of valence electron are same in all the groups. But from 5th onward, the valency is not 5. We know that when electrons are more than 4, we subtract the number of electrons from 8. So for nitrogen and phosphorus, the valency is 3. For oxygen and sulfur, valency is 2. For fluorine and chlorine, valency is 1. And for noble gases, valency is 0. They are having complete 8 octet. So they are inert and noble and the valency is 0. So after carbon, up to carbon, we have the valence electron and valency same. But after carbon, nitrogen, oxygen, fluorine, in nitrogen, we have to deduct the 5 valence electron from 8. The stable, for stable configuration, so it has 8 minus 5, 8 minus 6, 8 minus 7 and 8 minus 8. So it is having valency 3, 2, 1 and 0. This is how valencies are expressed in different groups. So this is about the valency and valence electron. Now one thing more, in groups, it is the most important one about the groups, that the 5th point, that the atomic size. And the atomic size, you know what is atomic size? The size of the atom. It decreases as we go from left to right in a group. In different groups, as we go from left to right, from suppose I have taken this third, this is the period. In groups, what I am saying, yes, in groups, first we will see the atomic size in periods. Later on I will discuss this characteristics, the size of atom in groups. So this is these are some of the properties of groups. And one thing more, as we go down the group, the number of shell, they are increasing. In first group, the topmost element has shell number 1, shell 1. The second element 2 shells, third element 3 shells, fourth element 4 shells. Likewise, the number of orbits or shells, they increase as we go down the group. Are you understanding this point? That hydrogen has only a single K shell. Then lithium, it has 2 shells, Kl. Sodium has 3 shells, Klm. And potassium has 4 shells. So as we go down, number of shells, they increase one by one as we go down the group. So these are some characteristics of group. Now we come to the periods. As for periods, you know there are 7 periods, and these are the horizontal rows. Horizontal rows are known as periods. So 7 periods, the number of period is 7. The second important characteristic, as you can see, in first period 2 elements are there. In second period 8 elements are there. In third period again 8 are there. In fourth period 18 elements are there. We will discuss it later why these elements are present in this manner: 2, 8, 8 and 18 and further 32 and more. So this point we will discuss later, but just you know that in the first period only 2 elements. This is a period, first period, second period, third period. So in the first period 2 elements are there. In second period 8 are there. In third 8 are there. No elements are there in this place. And in the fourth period, here 10 elements are here. 6 are here. 10 plus 6, 16 and 2, 18. So here also 18 elements are there. So this is the number of elements in different periods. The third important point is, as we go from left to right, the atomic number, it increases only by 1. In group, we have seen the atomic number increases by 2 or 8 or 18. But here, the atomic number increases only by 1. In a consecutive manner, the atomic numbers are there. So, the third point is atomic number increases by 1. Only by 1 the atomic numbers are increased. The next point is, fourth is, all the elements of a period have same number of shells. It is a very important point. Lithium has 2 shells, beryllium has 2 shells, boron 2, carbon 2, nitrogen 2. So here all the elements of second period, they have 2 shells, K, K and L. The elements of third period all have 3 shells, K, L, M. Fourth, K, L, M, N. The fourth period, they have 4 shells. So this is one of the important points. All elements of a period have same number of shells. This is one thing. Second, fifth point is number of period tells number of shells. What does it mean? If it is second period, there will be 2 shells. If it is fourth period, there will be 4 shells. If it will seventh period, there will be 7 shells. So the number of period is equal to number of shells. Now we should know about the valency and valence electron. What is the number of valence electron as we go down from left to right? Suppose I have taken this third period. Here the valence electron 1, we have just seen. Here valence electron 2, 3, 4, 5, 6, 7, 8. The valence electron increases by 1. In group, we have seen the valence electrons same. Here the valence electrons, they increase by 1. In sodium, 1 valence electron, magnesium 2, here 3, 4, 5, 6, 7, 8. So valence electrons, the 6th point we can write that valence electron increases as we go from left to right. Now the 7th point will be about the valency. What will be the valency? Valency we have just discussed when we were discussing group. In a period, in group we have seen the valency remains same, but in period the valency changes. How it changes? This is having valency 1, valency 2, valency 3, valency 4. So first valency increases from 1 to 4 and then it decreases 3 to 1. I just told you this has valency 3, this 2 and this 1, and then it has valency 0. So valency is, as we go from left to right in a period, first valency increases from 1 to 4 and then it decreases and then decreases from 3 to 0. After 4, the valency here will be 3, 2, 1 and 0. So about valency in a period, it decreases. First it increases up to 4 and then it decreases to 0. This is about some of the characteristics of groups and periods. And further, we will study about the trends in periodic table. So I will discuss in the next video just now.